lesson is 8.2. The goal is to find the angle and side measures in parallelograms. The first term we have to go over is parallelogram. So, it has a specific definition from the book. What definition did they give us in the book? Okay, anybody? A quadrilateral. So we'll say a four-sided shape in which opposite sides are parallel and congruent. Opposite sides are parallel and congruent. Sometimes in the book they will just say this first part. Opposite sides are parallel. Sometimes they'll just stop with that part. That is the key part. And it says it in parallelogram. So you got to key in on that part. Typically they look like this picture in 8.3. 8.3 is just talking about the concept of opposite sides being congruent. If opposite sides are congruent, what piece is equal to or congruent to segment RS? QP, good. So we can fill that in. QR would be congruent to PS. Very simple concept. 8.4 isn't much harder. It's talking about angles. We didn't really mention angles a second ago, but this is another true fact. It says if a quadrilateral is a parallelogram, then its opposite angles are congruent. Underline that fact. It's noted in the picture, but you've got to be able to visualize it yourself and draw in those marks if they're not marked. Angle P is congruent to angle R. And what is congruent to S? Pretty simple so far. Now we're going to do a little bit of algebra with these concepts in example 1. We're going to find the values of x and y. First off, let's find the value of x in the picture. It's over here. It's a side length. I have to compare it to another. What other side should I look at? I should look to JH and notice that they are both congruent. So I could say x plus 6 is equal to 13 since those segments are congruent. And now it's a simple algebra problem. How do I get x alone? Minus 6. We get 7. Pretty simple concept there. Y is pretty easy too. Y is located over here on angle H. Angle H is congruent to what in the picture? Angle F. Since they're both congruent, then they have the same measure. So the measure of angle Y is 68 degrees. Pretty simple so far. Theorem 8.5 adds a little bit more. It's talking about angles X and Y. When you focus on angle X and angle Y in the picture, you'll notice a special relationship. I can grab those angles, X and Y, and I can actually put them together. When I grab them and pull them over to the side, together they make a straight line. A straight line has what measure? 180. This means, what key math word? There, what? I heard it? Supplementary. Supplementary. They are a linear pair if they're side by side. I made a linear pair over here, but they're just supplementary when they're not next to each other. That's the key concept. Consecutive angles, ones that are side by side. On example 2, it wants you to use this concept. It says angle DAB is 65. So we can mark that angle. It's right here. That is 65 degrees. It says find ADC. ADC. So D, that middle letter, is right here. That's the angle I need to find. Are they consecutive? Are they side by side? That means they add up to 180. You could do the simple way of writing it. Two things add to 180 if they're supplementary. So we could say angle, measure of angle, ADC plus 65 is 180. Subtract 65, and what do we get? All right, so measure of angle ABC is 115. Pretty simple. Or sorry, X is right here. What should we compare that piece to? Oh, up to the 37 because they're congruent opposite sides. 2x minus 3 equals 37. Add 3 to each side. Divide by 2. We get 20. Who all got that right? Pretty much all of you. Good. Variable y is over here on this angle N. What should I compare that to? The opposite angle will be the same, so look at angle. They are the same measure. They're both 123. Good. Last thing, look for Z. Z in the picture is on this angle. What should I compare that to? I know that angle K and L are consecutive angles, therefore they add up to 180. Say K plus L is 180, and substitute. All right, subtract 123 from each side, and you get Z is 57. Theorem 8.6 says, if a quadrilateral is a parallelogram, then its diagonals something each other. They bisect each other. And if you don't remember what that word means, you can look it up. What does it mean? Okay, that means to cut into 2 equal parts. Good job. So QM in the picture is going to be congruent to MS, and PM is going to be congruent to MR. All right, example 3. The diagonals of parallelogram STUV intersect at point W. Find the coordinates of W. Well, whenever they're graphed, this is what you'll have to do on your own later, it's pretty easy to see. We just can find the coordinates of where the 2 diagonals intersect each other. So this is over 1, 2, 3 units. So it'll be 3, comma, how much does it go up? 1, 2.5. Perfect. Good job. All right, check point number 4. The diagonals of parallelogram V, W, X, Y intersect at point Z. Find the coordinates. Once again, we can either use the midpoint formula or count. The preferred method, usually when you already have it graphed, is to actually just count. So, first thing we'll need to do is count our X values. Over 1, 2, 3.5. Over 3.5. Up 4. Always make sure you have X, then Y. Oh, it's up 3. Yep. Midpoint formula would be this. Find the 2 opposite diagonals, or vertices. What are the coordinates? It would be 0, 0. And this coordinate would be 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4, 5, 6. This is a good question, by the way. Midpoint formula, once again, do you all remember it? Add the x's, divide by 2, add the y's, divide by 2. That's the formula. So adding the x's, that would be 0 plus 7, divide by 2, add the y's, 0 plus 6, divide by 2. 7 divided by 2 is 3.5. 6 divided by 2 is 3. Pretty simple. Good. Last one's finding these 2 values, MH and FH. MH is right here. It's part of this diagonal. If this half of the diagonal is 5, then MH is also 5. FH would be the whole length. 5 plus 5 is 10 units.